All right, 9.8, number 20. I'll read it out loud. The dimensions of a rectangular solid are in the ratio of 3 to 4 to 5. If the diagonal is 200 radical 2, find the three dimensions. All right. Case of the missing diagram. All right, they're in some ratio. There's some value of x that we're going to have to find that will allow this to work. And we know that our diagonal, let me go back to this real quick. We know that our diagonal is 200 radical 2. Okay, well, again, we know this pink line over here is 4x. Okay? What we need to find is this red diagonal of the base, and we need to find it in terms of x. So, remember that this is a right angle, it's a rectangular solid, and this here is 3x, and this is 5x. So I'll say 3x squared plus 5x squared is equal to, we'll just call that y for now, y squared. So you get 9x squared plus 25x squared, and that is 34x squared is equal to y squared. We want y. So y is the square root of 34x squared. So that makes y, remember the square root of x squared is x, so it's x times radical 34. That is what this is right here. Okay? And believe it or not, now it becomes a pretty easy problem. I know you guys don't like problems that involve so many funky radicals and a lot of weird x's, but now we just got to do Pythagorean theorem, because remember, this is also a right triangle. So I would just say 4x squared plus x radical 34 squared is equal to 200 radical 2 squared. Okay, so we get 16x squared plus 34x squared is equal to, oh dear, that's 4, 0, 0, 0, 0 times 2. So that is 80,000. All right, so 16x squared plus that's 50x squared is 80,000. Let me just make sure I got that right. Yep, okay. So divide each side by 50. And you get x squared is 1600. Nice, it worked out well. Take the square root of both sides. And you get x is 40. That's not 400, 40, sorry. So the dimensions of our rectangle then are 3 times 40. So 120 by 4 times 40, 160 by 5 times 40, which is 200. Tough problem. Boom!